today's episode of Pen and Paper, let's discuss the old tried and true paragraph proof. A paragraph proof is just a very nitpicky way of explaining why something works the way it does. This is our paragraph proof. Given that C is in between A and B, and segment AC is congruent to segment CB, write a paragraph proof to show that C is the midpoint of segment AB. The first thing that we're going to do is we're going to write out our given and proof statements in this form. We're going to say the phrase given, and we write out what we're given. C is between A and B, and segment AC is congruent to CB, segment CB. So we're going to say that. Given C is between A and B, and segment AC is congruent to segment CB. Okay, we write that out. Also, we write out what we're trying to prove. Prove C is the midpoint of line segment AB. Okay, so we write out our given pretty much exactly as it's written to us. We write out our prove pretty much exactly how it's given to us. The next thing that we're going to do is we're going to draw a picture for anything that we would need to. In this case, it tells us that C is in between A and B, and it tells us that AC is congruent to CB. So let's draw that picture. I have line segment AB, or at least I have 2 points A and B. I'm given that C is in between them, and also that AC is congruent to CB. So C is in between them. AC is congruent to CB, and I'm using those little tick marks to show that those two line segments are congruent or equal in measure to each other. Now I begin my proof. We're going to write out our proof. Like I said, we're just going to be very nitpicky and give every possible reason that we could. So I could say something to the fact that I have to show that C is the midpoint. So I'm kind of going to not work backwards. I need to show that C is the midpoint. If C is the midpoint, then I have to show that these two are equal in length. And how can I show that they're equal in length? Well, I can show that they're equal in length because that says so. And then I also need to show that C is in between. So what I'm going to do is that if C is in between if C is in between A and B, and also they are collinear, then AC plus CB equals AB. If AC is congruent to AB, segment AC is congruent to AB. I'm sorry, CB. Ugh. CB. Then, by definition of congruence, this is me giving my reason. By definition of congruence, AC equals CB. So this is what I did. I'm breaking things down. I'm literally taking the two parts of information that I was given in my given. C is in between A and B. Well, what does that mean? Well, that means they're on the same line, and then AC plus CB is going to equal to AB. All right. Then the second part that I'm given is that AC is congruent to CB. Well, what does that mean? Well, if AC is congruent to CB, then because they're congruent, AC's measure is equal to CB's measure. Okay. So what else do I need to prove? I guess that's really all I need to say. So by definition, of midpoint, just making sure you can see everything, since AC is equal to CB, then C is the midpoint of angle of line segment AB. Whenever I'm done my proof, I like to put a little box next to it. That just means I'm done. Okay, so again, it seems like we're being nitpicky. But I need to find a way to explain what I'm doing, and every time I give a little piece of information, I have to explain what I'm doing. I have to say, well, because of the definition of congruence, because of the definition of midpoint, blah, blah, blah. Okay, I think that'll do it. Bye.